So how we define current or electrical current? It's simply the flow of the charges or the movement of the charges in the wire is refers to current. Example, you have a wire and these are the electrical charges. Example, electrons are there. And these electrons move, or these charges move from one place to another. So flow of charges in unit time is simply refers to current or rate of flow of the charges. And current is equals to charge divided by time. So how many charges are moving in a unit time in 1 second? That is refers to electrical current. Example, unit of charge is coulombs and unit of time, the SI unit of time is seconds. So if I say I have 3 coulomb charges which flow from one place to another and took 4 seconds to move from one end of a conductor to another. So what is electrical current here? Current is the rate of flow of charges or number of charges which are moving through a circuit or through a wire in 1 second. So if 3 coulombs, so current is denoted by I, charge is 3 coulombs divided by time, which is 4 here in this. So 3 divided by 4, which is equals to 0.75 ampere. The SI unit of current is ampere. So simply the concept of the current is a rate of flow of the charges or flow of the charges in a unit time. And if you want to calculate a current is equals to charge divided by time. Is it clear, the concept of current?
Again, sir, please, I just entered.
Current means this is a flow of the charges in a unit time. Example, because when you have conductors, so how many charges, like these are the charges, it can be positive or negative, but normally electrons move. So how many charges move from one place to another in 1 second, or flow of the charges through a conductor in 1 second, that is known as electrical current. So example, if I say I have 5 charges here, or example, I have 5 coulomb, and it took 10 seconds to flow from one end of a conductor to another. So what is electrical current? So current is equals to charge, the number of the charges, divided by time, or flow of the charge in unit time. So how many charges were moving? There were 5 coulomb of a charge. And how much time it took? It took 10 seconds. So 5 divided by 10, that's equals to 0.5. So current is 0.5 amperes. What does it mean? It means half coulomb is flowing through a circuit or a wire or a component in 1 second. So definition of electrical current, it's a flow of the charges in the circuit. Current is denoted by I, and it is unit, its SI unit is ampere. But when, because some of the component, the current is too small, so we can also use milliampere. Ampere or milliampere can be used. And if you want to convert milliampere into ampere, 1 milliampere, milli means 10 power minus 3. So 1 milliampere is equals to 1 exponent minus 3 ampere. This is a unit conversion. The prefixes which we discussed in the first class, milli, micro, nano, pico. So this is M stands for milli, and milli means 10 power minus 3. So rate of flow of the charges, or the flow of the charges in a unit time, it simply refers to electrical current. Then for electrical current, we define two things. We say current can be, the flow can be conventional or it can be electron flow. Conventional current means the current which move from positive terminal of the battery to the negative terminal. That's called conventional current or simple current. And what is electron flow? Electron flow is a move from negative terminal to positive terminal of the battery. Because electrons are negative, so they are attracted towards opposite terminal. So example, if you have a battery, the big line is representing a positive terminal of the battery and small line is representing a negative terminal of the battery. And you connect a lamp to this. So if I say show the direction of conventional current or draw an arrow to show direction of conventional current. So conventional current is from positive terminal to negative. So from positive terminal you will start and you will end in the negative terminal. That's called conventional current. But what is electron flow or flow of the electrons? Because electrons are negative, so they're attracted towards the positive terminal. So when we represent the flow of electrons, so electrons travel from negative terminal and attracted towards a positive terminal. So this circuit is representing electron flow, which is from negative terminal to positive. This circuit is representing the conventional current, which is from positive to negative. And current is a rate of flow of the charges or flow of the charges in a unit time. Is it clear, the concept of current? The flow of the charges is called current. Current can be conventional current, which is from positive to negative, or it can be electron flow, which is from negative terminal to positive terminal. So conventional current direction is from positive to negative terminal and electron flow is opposite. So example, you can see in this picture you have a cell, and if I say show the direction of conventional current, if in this one, if I say show the direction of conventional current, so what will be the direction of conventional current? Direction of conventional current is from positive to negative. So this is a positive terminal, so you will show movement from positive to negative. But if I say what will be the direction of electron flow or movement of electron, so electron move from negative terminal to positive terminal. So it shows that direction of electron and direction of the current, conventional current, is always opposite of each other. So if in a question a wire is given, this is a wire, and the direction of conventional current is shown, this is the direction of the current. If we say state the direction of electron flow. Which direction electron will move if the current is from left to right? What is the direction of electron flow? So if the current is from left to right side, conventional current. Current or conventional current, same thing. So electron flow is always opposite to direction of the. So if conventional current is from left to right, so what is the direction of electron flow? Direction of electron flow will be opposite. It will be from right to left. So right to left represent electron flow here in this example. Left to right is representing a conventional current. So they are always opposite of each other. Same way, another circuit is there. If we say show the direction of conventional current or draw an arrow to show conventional current. So what is conventional current? It's from positive terminal to negative terminal. This is conventional current. But if electron flow is there, electron flow is opposite, so it's from negative terminal to positive terminal. Is it clear about the concept of current? In reality, conventional current is not there. In reality, conventional current is not there. It is just an assumption. Why it is an assumption? Because most of the laws related to electricity are derived by assuming that there is a movement from positive terminal to negative terminal. So later they found that in reality, actually, there is no movement from positive terminal to negative terminal. Actually, in reality, electrons are moving, but still they use this concept. Otherwise, they have to change different the signs used in the different laws. So that's why instead of changing those laws or signs used for the equation, they simply use conventional current.
Sir, but does it make any difference in the charge from positive to negative and negative to
No, it
positive?
does not make difference to the charge. It does not make any difference. It's only the idea is the directions are opposite. So most of the electricity laws are derived for conventional current, but later they found that in reality it's an electron movement, not the conventional current. But still these are the direction is used what was assumed. That's why we call that as conventional current. The instrument apparatus which we can use to measure the current, that's ammeter. And what is the symbol for this? This is how it looks like, the ammeter. And what is the symbol? Because in electricity we use electrical symbol. So symbol for ammeter is A. So example question. In 10 seconds, 60 coulomb of a charge flow around a circuit. Calculate the current. What's the current? In 10 seconds, 60 coulomb of a charge is flowing in 10 seconds. What's the current?
6.
So 60 divided by 10, which is equals to 6, and the SI unit of current is ampere, so it will be 6 ampere. Same thing, a current of 150 milliamperes, 150 milliamps flow in 3 minutes. How much electric charge flow around the circuit? What is the answer? A current of 150 milliampere is flowing around the circuit in 3 minutes. Keep in mind the time, the SI unit of time is second, so time should be in second. And SI unit of current is ampere, so it's milli, it should be in ampere. So milliampere to ampere, you will divide by 1000 or 10 exponent, it will be 150 into 10 to the power minus 3. And the time is 3 minutes, so it will be 3 multiplied by 60, which is equals to 180. You need a charge, as you know, the current is equals to charge divided by time. So you need charge, so charge is equals to current multiplied by time. So you have the current 150 milliamperes and you have the time, which is 380. When you multiply them, you will get the final answer, which is 27 coulombs. Is it clear? So basically the current, the electrical current, is the flow of the charges in a unit time. Then current in the circuit, a circuit can be a series circuit or it can be a parallel circuit. There are two types of circuits. Circuit means the region where the charges can flow, that's called a circuit. And circuit can be series, it can be parallel. What is the meaning of series circuit and what is the meaning of parallel circuit? Series circuit means if there is only one path for the charges to flow, we call that a series circuit. If they have multiple paths for charges to flow, we call that as parallel circuit. Example, this is a lamp. Example, two lamps are there. And I connect them. The red lines are representing the wires. So this is called a series circuit. Why it's called a series circuit? You can see only one path or one passage is there for the charges to flow. For a circuits, we always take conventional current. So when the particles are moving, conventional current is there. You can see there's only one track, one path for the charges to flow. If they have only one track or one path and they return back to the battery, this type of circuit is known as series circuit. But parallel circuit means they have multiple paths to flow. So if this is a symbol for lamp, So you can see here, the charges have multiple paths to flow. How the multiple paths look? If this charge is moving here, now it has two possibilities. Either can go up and return to the battery. This is one possibility. Or when this charge is moving, it can go down and return to the battery. So when charges have multiple paths to flow, that type of a circuit is known as parallel circuit. So you always have two types, like there are only two types of circuit. Combination can be there, like some circuits are combination of series and parallel, but in practical there are two types of circuits. One is called series. If we have one passage for the charges to flow, one path for the charges to flow, as you can see here, if the charges enter from positive terminal, they have only one passage or one part to flow. That's why we call that as series. But if they enter from here, they have multiple passage like paths available. They can flow from top also, and it can flow from bottom as well. So current in circuits, series and parallel circuit. So current in series circuit is same at all the points. So what does it mean? Example, if I say 2 ampere is coming out from the battery. 2 ampere means two charges are moving in 1 second. So if 2 ampere is coming out from the battery, how much current will be there before entering 2 ampere? How much current will pass through 2 ampere? How much current will pass through lamp 2, the second lamp 2 ampere? And how much current will return? The same amount of current will return to the battery what is entered. So in series circuit, the current is always same. It remains same throughout the circuit or any point in the circuit. But what happened in parallel circuit example, the same 2 ampere is coming out from the parallel circuit. So here it will be 2. Before entering the branches, these are the branches in which so when the moment when the current enter, now it has two possibilities. Some of the current can flow up. So some current flow up, like example, if 1 ampere flow up, how much current will flow down? Same 1 ampere will flow down. So basically in parallel circuit, the current divide between the components.
So it will be less energy to the bulbs.
Energy is known as a voltage. It's about number of the charges moving through the lamp. So number of the charges which are flowing through a lamp in 1 second will be smaller as compared to number of the charges which enter the circuit. You can see 2 ampere means 2 coulomb of a charge is flowing through in 1 second. But when they enter the branches, it become half of it. So half of the charges will move through one component and remaining will pass through another component. But it is not necessary that it should always be half. It also depends on another factor which is called resistance of a component. But right now, because it's a beginning at the start, so you will consider that it divide equally. But in practical, it does not divide equally. It depends on resistance of the components as well.
So sir, does it have an effect on the voltage? Like, I mean, will the bulb be dimmer than the
Voltage is
series
another thing.
circuit?
Voltage is how much energy supplied by the charge. The brightness of the bulb or the brightness of the lamp depends on voltage rather than current. So in the topic, I will answer your question in topic voltage rather than your now, because the voltage is different concept, current is a different concept. Current is just a movement of the charges or flow of the charges. So example, if two charges are moving in 1 second, but when they enter branches there, so half of the charge or one charge will flow through first component, the remaining half will flow through the second component. How much is the current here at this point? What will be the current at this point? The current will be 2 ampere, because what happened? These two charges rejoin again and then it makes 2 ampere, and 2 ampere will return back. So you can see here the total current which entered the circuit is always same as the total current leave the circuit. The total current enter the circuit is always same as total current leave the circuit, even though it is a series circuit or even it's a parallel circuit. So it does not make difference. The total current will be same, but if it's a series circuit, throughout the circuit, the total current will be, the current will be same. But if it's a parallel, the current will divide between the components and rejoin again, and same current will return back to the battery. Is it clear, the concept of current in the circuit? So I want you to copy this part because this is an extra thing I wrote, not in the presentation. So copy this one. If you want to measure the current in the circuit, so how we can measure the current in the circuit? We can use an ammeter. So connection of ammeter.
Sir, ammeter the same as voltmeter?
No, ammeter is for current, voltmeter is for voltage. If we want to measure the current, we use ammeter. So example, an ammeter are always connected in series. What is the reason why we connect ammeter in series to a component which we are measuring a current? Because in series the current is same. So what current is flowing through the component, same current will flow through ammeter. So example, if this is a circuit which contain 3 lamps, 2 of the lamps are connected in parallel to each other. And one of them is connected in series to this parallel combination. So example, from the battery, 3 ampere is coming out from the battery. 3 ampere means 3 coulomb of a charge is flowing in 1 second. Before entering, what is the current here at this point? Before entering the branch, what's the current at this point? That will be 3. Example, out of this 3, if 1 ampere flow through the first branch, how much current will flow through the second branch? So 2 ampere will flow through the second branch. And then the same current will pass. Here it's 2 ampere and this part is 1 ampere. How much current will be at this point? What will be the current? So it will be 3 ampere. And how much current will return to the battery? The same 3 ampere can return to the battery. Current can be in decimals or fraction. Like it can be 1.5, 2.5, 1.25 ampere. So the total current enter is equals to total current leave. Now, what we want to do, we want to measure a current in, like example, if I say this is lamp 1, this one is lamp 2, and here is lamp 3. So if I want to measure the current in these lamps, I should connect an ammeter. The symbol, the circuit symbol for ammeter is a circle with letter A written inside. So that's a circuit symbol for ammeter. So if I want to measure the current in the component, example, if I want to measure the current coming from the battery, so what I should do, or ammeter are always connected in series to the component. Like if I want to measure the current from the battery, so I can connect before or after the battery to measure the current. So I will connect an ammeter here. It can be before or after the battery. So this will give what is the current coming out from the battery. If I want to
It shouldn't
measure,
be in the branch.
no, I want to measure the current coming out from the battery. That's why I connect next to the battery. In the explanation I mentioned, I'm measuring a current which is coming out from the battery or current from the supply. So ammeter are always connected to a component which we are measuring a current. If we are measuring a current of the supply, so we connect ammeter to the supply. If a question is connect an ammeter to measure current in lamp 1. So how to measure current in lamp 1? So you can connect ammeter before or after, it will not make difference. So you connect an ammeter before lamp 1 so that you can measure current in lamp 1. If I say I want to measure current in lamp 2, so what I will do, I will connect before or after lamp 2 an ammeter so that I can measure current in. And if I want to measure current in lamp 3, so I can also connect before or after and measure current in lamp 3. So basically ammeter, you can see, are always connected in series to a component. It's not about whole circuit. It's always in series to a component which we are measuring a current. So if I'm measuring a current of the battery, I should connect ammeter next to the battery. If I'm measuring a current in lamp 1, so I should place ammeter next to lamp 1. But for example, if I connect them in parallel, so what will happen? So whenever we connect an ammeter, ammeter is always connected in series or next to the component. So if a question is connect an ammeter to measure current in the battery. So to measure current in the battery, you will connect ammeter either before or after. If you want to measure current in lamp 1, so ammeter should be before or after. Lamp 2, it can be before or after. So another circuit, and I want to measure. So these are the three lamps. Because the current is same in series, so we always connect ammeter in series to a component. So if I say connect an ammeter to measure current in the battery, current which is coming out from the battery. So where I will connect an ammeter? So because this is a battery, so ammeter before or after. That will give us the current which is coming out from the battery. If I want to measure current in lamp 1, actually current in lamp 1 is same as current which is coming out from the battery. So practically we don't connect an ammeter here. Why? Because it will not make any difference. It will be same value as what is original. So because this ammeter will record the current in the battery as well as current in lamp 1. But if I want to measure current in lamp 2, so this is lamp 2. I want to measure current in the second lamp. So ammeter before or after. If I want to measure current in lamp 3, so ammeter will be before or after the component. If lamp ammeter, this ammeter read 2 ampere and this ammeter read 3 ampere, what will be the reading of this ammeter before L1? What is the reading of ammeter before L1? That's equal to 5 ampere. And what is the reading of the first ammeter? That's also 5 ampere. So basically 5 ampere enter, out of 5, 2 ampere break into one branch and 3 ampere